Okay, so grab your graphing calculators. I want you to type in this equation. We're going to make up a quadratic equation. So you can borrow one. So negative 8, let's keep it small because I don't want it to be off the graph too much. 2. Okay, 2x squared plus 6x plus minus plus, okay, minus 4. And push graph. So hopefully this is there you go. Okay, actually, can you go back to y equals? Can we move this guy? How could we shift this graph up? What's the y-intercept? Looking at this. So y-intercept would be -4. So if we want to shift it up, right now we'll make it maybe a +4. Let's see if that helps. There you go. So what we want to do is find the x-intercepts. And I'm going to teach you how we can do that with our calculator. Cool? Okay, so there's another name for x-intercepts, and they're called zeros. Why do you think they're called zeros? When the y is 0. Yeah. So where do we go for all our calculator solving? Second trace, or calc. Second trace. So number 2 is 0. Now, you do have to do a little work. You have to pick which x-intercept you're solving for first. So which one do you want to do? The one on the left? Okay. So it says left bound. So what that means is you have to be on the left side of the x-intercept. Do you have -2x squared plus 6x plus 4? Did you go zoom plus 4? Plus 4. And then zoom 6 to make sure your windows are the same. Okay, so you have to go on the left side. Yeah, left side of the 0, and then push enter. Then you need to go on the right side of the 0. Push enter. So notice how my arrows, we're saying we want the 0 between these 2 points. Right? The arrows should always be pointing towards each other. If they're pointing outwards, you have a problem. It won't solve it. And then it says make a guess. So we go down, it's around there somewhere. Enter. And there it is. So that would be my x-intercepts, -0.561. Okay, now let's find the other one. So it's on the other side. What button would you have to push first? Dean.
Enter. No.
Second, we're finding the 0.
Oh, second trace.
Trace the number. What number now? Which one's going to give us the x-intercept? 2, 0. The zeros. And this time we want to be the left. We want to go on the other side. Now it says left side of the 0. Which side is on the left of the 0? Here or on below? No, this side. This is the left side of the 0. Enter. And then down. Now that's the right side of the 0. See, the arrows have to be pointing in towards each other. We're trying to find out the x-intercept. And then push enter. And there it is, 3.561 approximately. So could you use that to find your x-intercepts? Yeah. Exactly. So that means you're not doing it on the left and the right. If the arrows face out. So if I go second trace, number 2, this is on the left side of that 0. So there's the left side, then this is the right side of the 0. Left and right, and then guess, and then you'll get it. That -1 times 10 to the -12 is basically 0. Yeah, very close to 0. Okay, so that's finding zeros on your calculator. Could you find the maximum of this graph? How could we find the maximum? Second trace. 4 for maximum. Left of what this time? The curve on the top, the bump. So left of the bump, anywhere on the left, anywhere on the right of it, and then it says make a guess. So it's about there. And so the maximum here would be at 1.5 and 8.5. Okay? Yeah. So and remember, that's the calculator does that. Okay, and so if I wanted the y-intercept on your calculator, what could you push right now? trace,
Zero.
trace, 0, enter. There it is, it's 4. Trace, 0, enter. Okay? So your calculator can basically do almost everything for you. Yeah. Okay, but today we're going to get into applications. So we're going to do one example, and the rest of the time will be for homework. Okay? So let's look at this example. During a high school football game, the height of a punt, what does it mean to punt? Yeah, you do little kick, can be modeled as a quadratic function over time. Is it a huge kick? No. I don't know. It's a kick. Yeah, I think when you punted it actually is a big kick. Yeah. Just sounds so little when you say punt. Maybe because it rhymes with runt. Okay, so let's look at this equation. What's our y value in this context of our equation? What's the y? Not the y-intercept, just like the y variable. What's the dependent variable? Guys, what is the y? Instead of using a y, what variable do they use? H of t. So what do you think the h of t stands for? That's your y. And in the context of the question, what does it stand for? Height. The height. Height in, they even say it. Height, h of t is the number of meters above the ground. It's the height above the ground. And instead of x, what are we using? T, and t is the seconds, the time in seconds. So h is in meters, t is in seconds. So that's something you want to keep straight, that they're using y as your height and x is the time. Okay? Yeah, exactly. You have to pay attention to the equation. Now that says, without using graphing feature, explain how we can determine the maximum height. Now, looking at this equation, what form is it in right now? Looking at your yellow sheet, is it general? Is it standard? Standard form. So remember, standard form looked like this. Y equals negative a x minus h squared plus k. And what did h comma k stand for? The x and y of what? The vertex. So could we get the maximum height? Yeah, what's the vertex? Looking at our original equation, what would the h value be? Would it be negative 1.5, our h value? Remember, it's a minus sign, so the x inside is opposite. So it would be 1.5, comma, and the k value would be 12.25. Okay, now we're not done the question. Which part would be the maximum height? 12.25, the y value, which is actually in meters. So the maximum height is, it's not bad. High? The maximum height is 12 point, it's probably me kicking then. That's meter. Yeah, how many feet? How many feet are in a meter? 3 point, guys remember? It's like 3.1. I'm pretty sure. 3 point, it's on your formula sheet. Okay, so the time it takes to reach the maximum height. What time would it take to reach the maximum height? 1.5 seconds. That would be the x value, or your time. So remember, this is time, comma, height. So it would take 1.5 seconds to reach the maximum height. Okay. All right, so now it says the height of the football above the ground as the punter makes contact with it. So we're looking for the height. So which variable is going to be the height? We're looking for h, and it says above the ground as the punter make contact. So we obviously need to know something about the time. What time is it that we actually make contact with the ground? 0. That's our 0. So that's when time equals 0. So how do we get our height when time equals 0? What can we do? We know time is 0. plug it in. Plug it into the equation. Why not into the equation? Well, you're going to type it into your calculator too. But so negative 5 times, our time is 0 minus 1.5 squared plus 12.25. Okay, so grabbing your calculator, let's quit out of here. So we have negative 5 times, in brackets, 0 minus 1.5 brackets squared plus 12.25. 1. 1 what? 1 meter. So when he makes contact about 1 meter above the ground. I don't know if I can kick that. Probably. Where's 1 meter? It's like there, right? Boom. Okay. The height of the football above the ground, 0.5 seconds after contact. So how would we find the height at 0.5 seconds? Which one did they give us? Like height or the time? Time. They gave us time equals 0.5. So what could we do? Plug it in. Right. Substitute our time as, I should actually write this as h of 0.5 equals negative 5 times 0.5 minus 1.5 squared plus 12.25. So negative 5, so we can just go second enter to get the equation again and just replace our zeros. Now, does anyone know how to insert, if they wanted to insert more here? Did you know you have an insert button? Second delete is your insert. So it blinks, and then I can push 0.5. There you go. 7.25. 7.25. 7.25 what? Yeah? Meters above the ground. Use the feature. Okay, so we're going to sketch the graph that we have. We're going to use these features that we just found out. So up above, you have a graph. We're going to use our calculator right away, but we can also plot the points we know, right? We know where are you when you leave the ground? How high is at 0 seconds, how high is the ball? We solved. It was 1. It was at 1, right? And we want to get to a maximum height of 12.25. So we need about 12 picks. 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here's where we're leaving the ground. And how many seconds is halfway at our maximum value? 1.5. So we need to go at least to 3, maybe more. Right? So 1 second, 2 seconds, 3 seconds. Right? So our first point that we know for sure, Jesse, we know that it left at 1 meter. What's another point we know? Which one? The maximum height was? When was that? 1.5 seconds, it got to 12.25. So 1.5 seconds, it was 12.25. What else do we know? At 1 second, or what else did they ask us? At 0.5 seconds, how high was it? 7.25. So 1, 2, 3, 4, 5, 6, 7, and that's at about half. Okay, so let's graph the rest. Go to your y equals. Let's plug in our equation. Okay, so negative 5, and the key here is to use the very similar windows that we have made. Negative 5, can we actually type t? Or what are you going to push? X. X minus 1.5 squared plus 12.25. Did I forget something? 12.25. There you go. And what should go to Windows? What's our minimum window for X? 0. Why does it make sense in the context of this question to start at 0? Can't be underneath the ground for height, and you can't have negative time. So 0, 2, our x value, we said at least 3, so maybe we should go to 4. 5, let's go 4. The reason why I said that, John, is my x-intercept, like this is our halfway mark at 1.5. So most likely it's going to be somewhere over here that's crossing. Okay, scale of, maybe let's do 0.5. Minimum y value, minimum y. 0. Maximum 13, sure. And scales 1's okay. Okay, so there's our windows and graph. So where does it look like it's crossing? Remember, these are half. So this is 1, 2, looks like it's landing on 3. That's where it looks like it's landing on. Okay, so we're going to sketch this. It's our maximum height, and then it falls to 3. There's the height with respect to time. Yay! Okay, we're not done. There's more questions. So now there's our graph. Shoot. Okay. Now, determine how, after how many seconds, so this time we're looking for what value. This is really important, this part, because it's going to be new. This is where stuff gets new. If we're looking for seconds, which variable is that? T. We're looking for time. The nearest tenth that the football is 10 meters above the ground. So they give us the H. What do you mean? What is the thing for that? How would you do that? They give you the y value. Okay, you're saying, Jesse, we could just plug this in. You're thinking going second trace, then something. 2 is zeros. That's when it hits the ground. You're actually right. You're going to use something on here, but we have to do something first. We want when our height is 10. What is your height, x or y? We want when y is 10. So what we're going to do is we're going to introduce another y variable. We're going to do, we want when y is 10. Right here. Jessica, come on. No. So, and graph it. So we want when y is 10. Right. So whenever they give us a y value, we want when y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. We're going to find 2 intersection points. Why is there 2 times that it's going to reach a 10 meters? Goes up, and then it goes back down again. Right. Okay, so now, so the first thing we need to do is go y2 equals 10. Whenever they give us the y value. Make a second one, and then what we're going to find, what do we have to do now? Intersection. Okay, so let's find the intersection. Now, there's 2 intersections. So do one at a time. Second, trace, 5. Do we have to do anything? Scroll to the one you want first. Second, trace 5. Do what? Put it somewhere else? Oh, because when I hold it down on the smart board, it just automatically, it's like right-clicking when you hold it down, see? Yeah. Okay, so now, enter, enter, enter. So one solution is 0.829 or 0.83 seconds. So 0.83 seconds, and let's find the other one. What would you push? Second, trace, 5, then what? Scroll to that side. No, I can't, because then it wriggles. Enter, enter, enter. And 2 point, round to the nearest tenth. 2.2 seconds. Actually, this one said to the nearest tenth, so it would actually be 0.8 seconds here. And 2.2 seconds. Okay, the punt is not caught by the opposing team and the football hits the ground. Uh-oh. Use the feature of the graphic calculator to determine how many seconds the nearest tenth, hundredth it took for the ball to hit the ground. So now, when we want y is 0, so which function will give us when y equals 0? Second trace 2. Second trace 2. Now we have to go on the left side of 0. Now what's the problem with our picture? You can't see, but that's okay. So this is on the left side, enter. I go on the right side, so until I can't see it, enter, and then back up a little bit, and there it is. So when does it hit the ground? To the nearest tenth? 3.1. Want me to go through that again? So second trace, 2 gives you zeros. We want the intersection with the x-axis. So left side so you can see it. Right side is when you can't see it anymore because you want to go on the other, it's below. So you don't see it, then push enter, and then back up a bit, enter. 3.1. Okay, so we use second, trace, 2 for zeros, and we got 3 point, what's wrong? 3.1 seconds. Okay. All right. So your homework, we're going to omit number 4. So if you turn the page, number 1, 2, 3, omit 4, so that's that page. But then 5, 6, 7, 8 is fine. So everything but 4. So that just shortens it a bit for you. If you finish early, you could try that question. Maybe I'll give an extra bonus for it if you do finish early. But for now, numbers 1 to 3, 5 to 8 is your homework.